Testing. Testing, testing. Testing, testing. We're doing some testing of the microphone to make sure that the volume is good. And we will continue to test until we have confirmed that the volume is good. Is the volume good? All right, sounds like the volume is good. Welcome, happy Friday. We got an interesting stream today. We're going to be looking at PDF summarizers. So, since GPT has been released, there's been a couple kind of wrappers over GPT that allow you to kind of talk to a PDF. So, I did a little bit of browsing, and I basically found that there's two that seem to be kind of dominant here. We have PDF-GPT.io and then ChatPDF.com. So I went ahead and I downloaded a paper. This is a paper that someone in our Discord recommended, and it's kind of a generic summary paper of deep learning. So what we're going to be doing is we're going to be giving this PDF to both of these PDF chat bots, and then we're going to see how they do in terms of finding information, and then we're also going to see how they do compared to GPT-4. So GPT-4 obviously does not know this exact PDF, but it has kind of generalist knowledge, so maybe it does well, maybe it does not do well. We'll see. So first thing we're going to do here is we are going to open up our good old file browser. We're going to go into our downloads, and we are going to put in this PDF, the deep learning survey, and we're also going to upload the same PDF into here. All right, so both of them have processed it. It took like very few time, right? So this really has me thinking about whether they actually uploaded the document and like read the entire thing, or whether they basically just said, hey, we acknowledge that you've uploaded it, right? Because I have a feeling that the amount of time that passed is not enough time to scrape this entire PDF for text and then feed all that text into GPT. So I don't think it's actually read the entire thing yet. I think it's just loaded it. So next thing, kind of maybe on the interface here. I do like this interface, the fact that in PDF-GPT you have the PDF on the side here. I think I like that implementation, right? I like being able to do that. I don't like that here in Chat PDF, you don't have the PDF anymore. You would have to kind of do this. So let's ask it for something a little bit generic. Let's start with an easy question. Let's say, what is deep learning in 2 sentences? What is deep learning in 1 sentence? Explain deep learning in a couple sentences. Okay, so we're going to ask ChatPDF. We're going to ask PDF-GPT. And then we're going to ask GPT-4. Okay. Deep learning is a subfield of machine learning that uses artificial neural networks to model and solve complex problems. It involves training these networks on large amounts of data to learn patterns and make predictions or decisions. That seems correct. And kind of what I'm looking for here is I'm looking to see if the response changes. So obviously both of these under the hood are just GPT. So I want to see what happens when you give it the PDF and now it has kind of information that potentially overrides whatever it has in the original kind of GPT answer. So I kind of want to see how much different it is to this one, right? So right off the bat, I'm seeing that the ChatPDF and GPT-4 are very similar here. Deep learning is a subfield of artificial intelligence that involves training artificial neural networks to recognize patterns, make decisions, and learn from experience. Model and solve complex problems. One thing I've noticed is that the wording is very important, right? So ChatGPT being an LLM, like the amount of attention it pays to the actual like tokens is huge, right? It's like recognizing patterns that you don't even recognize as a human. Like it knows that if you use specific words, you're kind of putting it into a specific like area of its kind of embedding space, right? And you might not even realize that you're doing that. So sometimes even just changing words around, or the fact that it uses some words and not other words, can tell you a lot. Inspired by the structure and function of the human brains. Like, for example, inspired here, right? That's not a word that appears at all here. Let's see if it appears here. Ooh, this one has references. Oh, that's kind of cool. I like that. Okay, so this ChatPDF just kind of gave me an answer, which is actually very similar to the GPT-4 answer. But PDF-GPT gave me an answer, and it looks like this one's a little bit more specific to the paper. So it looks like it pulled it specifically from the paper, and then it actually gave references to the exact paper. So this is saying page 33 in this paper. Subfield of machine learning. Procedure consisting of estimating the model parameters such that the learn, blah, blah, strategies of non-linear information processing units with hierarchical architectures that are exploited for feature learning and pattern recognition. Yeah, this feels like it's much more from the paper. Okay, so far, PDF-GPT 1, ChatPDF 0. ChatPDF just kind of gave us the GPT-4 answer. PDF-GPT gave us something specific to this paper. So let's keep going here. Let's find something a little bit more complicated that perhaps ChatGPT does not know about. So in this summary paper, they talk about the different types of deep learning approaches. You got semi-supervised, supervised, partially supervised, and unsupervised. You got reinforcement learning, you got deep reinforcement learning. Does anybody actually do reinforcement learning anymore that's not deep reinforcement learning? Supervised learning, semi-supervised learning, unsupervised learning. Let's see if... So this right here, this breakup into supervised, semi-supervised, partially supervised, or unsupervised, that's not necessarily... Like sometimes it's broken up differently, right? You can just break it up as supervised, unsupervised. So let's see. What are the different types of supervised learning? Let's see what that has to answer. Oh, we gotta send, send, send it. Okay. Supervised learning is a machine learning paradigm where an algorithm learns from labeled data using input-output pairs to make predictions. Yep, that's correct. There are two main types of supervised learning. Regression. Goal is to predict a continuous numerical value. Okay, and classification. The goal is to predict which category an input belongs to. So that seems all relatively correct. Let's look at here. You see here, PDF-GPT might be winning this again. Look at this. You see, this is much more from the paper. So it goes supervised, semi-supervised, unsupervised. So you have supervised, semi-supervised, and unsupervised. And it also talks about deep reinforcement learning here. Deep reinforcement learning began in 2013 with Google DeepMind. That is not necessarily true. I think people were doing that beforehand. Okay, but I do like how it gave us the 3 things here from the paper. How many pages and you feed into it? This paper is pretty long, so I specifically chose papers that are long here. I have another one here, like this is like a history paper, but this is 39 pages. So it's very unlikely that it read the entire thing. I think it's probably doing some kind of similarity search. And let's look at ChatPDF here. According to the PDF file, there are different types of supervised learning for deep learning, including deep neural networks, convolutional neural networks, recurrent neural networks. Oh shit, I just realized we gave it a wrong word here. We mistyped it. We called it supervised. ChatPDF actually did the worst here. There are different types of unsupervised learning, recurrent, gated recurrent units. These are like just architectures. These aren't actually even, sorry, I realize this is not, you guys can't see this, my bad. Let me switch it over like this. So ChatPDF not doing great here. This is not actually any type of supervised learning. This is model architectures. It's just kind of giving you a generic model architecture paragraph. PDF-GPT a little bit better. And then, of course, GPT-4. Probably the best answer in terms of succinctness and kind of actually giving you the right idea. Okay. The famous Jan LeCun cake, right? If you guys have never heard of this. Jan LeCun cake. Just in case you see it in like a presentation at a paper conference or at some kind of conference and now you know the joke, basically it's this cake. So Jan LeCun is famous for this, but basically he always talks about how the cherry on top is the reinforcement learning and the meat of the cake is basically unsupervised learning and or self-supervised learning, which is kind of the same thing. And actually, this analogy became true, right? When you think about it, how is ChatGPT trained? The majority of it is next token prediction, which is a kind of a form of self-supervised learning or even unsupervised learning. And the cherry on top is the RLHF, which is reinforcement learning from human feedback. So in a way, he was actually correct. So as much shit as people give him for that, he was actually correct in that. Okay, let's see. Key difference between traditional ML and DL is how features are extracted. Okay, let's see. We're going to copy this sentence kind of exactly, right? What is a key difference between traditional ML and DL, right? And what I'm looking for here is the fact that this is a very specific kind of phrase, right? A specific sequence of tokens here. So if either of these PDF GPTs are doing some kind of similarity search, they're gonna hit it right here. They're gonna land exactly here because I'm copy pasting an exact sentence from it. So that's kind of what I'm looking for. I'm looking to see if they give me the exact thing. So put that there. Answer all 3 of these. Okay. So what does GPT-4 tell us? A key difference between traditional machine learning and deep learning lies in their feature representation and learning approach. In traditional ML, the most critical step is feature engineering, where domain experts manually select, extract, and transform the most relevant features from raw data to represent the problem. ML algorithms then learn from these handcrafted features to make predictions. This is correct. I would say there's still plenty of feature engineering in the deep learning world, but it's moved kind of more closer to the data, right? So feature engineering in the modern deep learning world is actually mostly called data cleaning, right? But like when you're cleaning a data set, like what are you really doing? You're basically engineering the features, right? But what GPT is referring to here is that it used to be the case that not only would you clean the data, but you would also basically, for example, in computer vision, you would choose which actual feature maps you would convolve around on your image, right? You would maybe choose a specific descriptor such as sift or orb for key points. And you don't really have to do that anymore, right? Now you put the image in its raw form, you still have to clean the data set, but the convolutional neural network is going to create an embedding space of features that is relevant to your problem without you having to design it by hand. Let's see what PDF-GPT said. A key difference between traditional machine learning and deep learning is how features are extracted. You see? Boom. How features are extracted. So it definitely is doing some kind of similarity search here. Traditional ML approaches use handmade features by applying several feature extraction algorithms. This is exact. Yeah, look at that. While DL features are learned automatically. On the other hand, in the case of DL, the features are learned automatically. So this is actually pretty impressive. You see that? It gave you the word for word here for the ML, and then it went straight to the word for word here for the DL, right? And it broke it into kind of a sentence with two parts here. So it's kind of copy pasting from the PDF, but it's actually aware of kind of the knowledge. So let's look at ChatPDF here. According to the PDF file, a key difference between traditional machine and deep learning is how features are extracted. Okay, so ChatPDF also did some kind of similarity search and was able to find this exact part, right? There you go, there's the magic word, in how features are extracted. Traditional ML approaches use handmade features by applying blah, 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 while DL uses artificial neural networks to automatically learn features. While DL features are learned automatically and represent hierarchically in multiple levels. So this is a little bit more similar, right? We're starting to see PDF-GPT and ChatPDF kind of gave us the same answer there, which is curious. This makes DL more suitable. This is the strong point of DL against traditional ML approaches. So the structure is kind of the same. Obviously the tokens are different, but it seems like they're actually giving us the same answer here. I also like how here it references page number 3. So you have this kind of like, you can click here and it'll tell you where it got the reference, and the same kind of thing here, except here in ChatPDF it's in the answer, right? So it just straight up tells you here. So I kind of like the fact that here you can click on it. So far the PDF-GPT seems to have the better UI. I like the UI. I like that you have the thing on the side, the show PDF. And I like the references here, the fact that you can click and I guess go here and click on that and it'll go to page 2. That's very nice, right? So in terms of the UI, this one seems better. In terms of the answer, they're both kind of giving us similar answer here. Both of them were able to find that exact part of the book. And in terms of correctness, obviously both of them are kind of about the same, but these questions are pretty easy. So let's try to find something that's like kind of obscure, right? Some like the date for some specific paper, right? Like that seems like big data analytics in 2014. That seems too easy, right? I want like a very obscure paper date and then see if ChatGPT gets it. So I want something that I know GPT-4 doesn't know, right? So let's try to find something that GPT-4 probably will not know. Weight decay, momentum, backpropagation, SGD. These are all just kind of basic concepts. GPT-4 is for sure going to know it. Network structure was first proposed by Fukushima in 1988. Maybe it doesn't know this. Let's see if GPT-4 knows this. When did Fukushima first describe the CNN? It wasn't even a CNN. I think he described an MLP at that time. I'm not sure. All right, let's ask ChatGPT. Let's ask PDF-GPT, and let's ask ChatPDF. Fukushima first described the concept of CNNs in a series of papers published between 1979 and 1980. Okay, so 1988 is actually the date here in the PDF, so something is wrong. The text does not provide information on when Fukushima first described the CNN. Oh no. Okay, there you go. So Chat, PDF, GPT, not able to find this. I think because the word CNN is not here in this sentence, right? So it says CNN overview, but that's part of the title. And then here, the first sentence with the 1988 does not contain the tokens for CNN. So maybe that's where it got confused. Let's look at ChatPDF. Oh shit, look at it. ChatPDF got it. According to the PDF file, Fukushima first proposed the CNN in 1988. All right. Good old ChatPDF doing good here. And GPT-4 gave us a hallucinated wrong answer, but let's double check this. Fukushima CNN paper. A self-organizing neural network model for a mechanism of pattern recognition unaffected by shift in position. So this is sometimes when you hear people describe CNNs, they'll talk about translation invariance and translation or translation spatial bias, basically. And what they mean is that the way that a ConvNet works, it doesn't matter if the dog is in the center of the image or in the corner of the image or in the bottom corner of the image, because you're convolving this feature map across the image, right? So it's invariant to the spatial position of the dog in the image, right? So that's kind of what he means here by unaffected by the shift in position. So, I mean, this is interesting here, right? Because this paper was released in 1980, and this is very clearly describing a convolutional neural net, right? That this looks like a ConvNet. So I feel like this is wrong, right? Even this survey paper tells us it's 1988, but this was already an idea in 1980. So there you go. ChatGPT was actually correct. So damn, look at that. If I would have read this paper, I would have thought that this paper was correct and ChatGPT was actually incorrect, but it turns out that ChatGPT is correct because the Neocognitron paper came out in 1980, not in 1988. So there you go. That's a mind bender right there. All right, let's find another thing. Let's find something that's like a little bit of a hard concept. Kernels, learnable kernels, different types of activation functions. It's probably going to know that. Complexity, the number of parameters, the dimensions of the input feature maps. This is just convolutional nets, kind of 101 here. I feel like we've got to find something very obscure. Okay, so AlexNet, which was a famous ConvNet that won, I think, the ImageNet awards. It was one of the very first ConvNets. And two networks, two new concepts. LRN, local response normalization, which is kind of like a type of regularization, right? Kind of like layer norm or batch norm, one of those type of things. And dropout are introduced in this network. Okay, so let's see of what new, let's true that. What new types of architecture design did AlexNet introduce? God. Okay, we're gonna ask that. We're gonna ask PDF-GPT, and we're gonna ask ChatPDF. All right, let's see what GPT-4 gave us. AlexNet, proposed by blah, blah, blah. This is actually the OpenAI founder, BT-dub, guys. Ilya here. Was a breakthrough in deep learning, particularly in the field of computer vision. It builds upon the foundational concepts of CNNs and introduced several key innovations. Larger and deeper network. Okay, cool. That's kind of an easy one to pick, though. What I'm really interested in is see if it gets this LRN. ReLU activation function. I did not know that. Is that true? The ReLU is from AlexNet? I thought the ReLU is older than that. Oh, here you go. Dropout. Boom. Nice. Okay, so it did get the dropout. Let's see what PDF-GPT is. Deeper and wider model. Okay. Here you go. LRN. It got that. So PDF-GPT doing well, getting the LRN and getting the dropout. Deeper and wider. You see how both of them have this deeper and wider. So both of them kind of centered in on that particular kind of sequence of tokens there, deeper and wider. At 5 convolutional layers, followed by 3 convolutional layers, fully connected. Use rectified linear units. Also use dropout regularization to prevent overfitting. Dropout to regularize the network. It does not talk about this local response normalization. So you see, ChatPDF maybe a little bit more succinct. Like this one seems PDF-GPT a little bit more wordy, but both of them got the dropout. PDF-GPT got the layer local response normalization. ChatPDF did not get the local response normalization, and neither did GPT-4, but GPT-4 did get the dropout. Cool. Let's keep going. Got GoogleNet, the winner of ILS VRC. Good old Inception Net, I remember that. ResNet was developed with the intent of designing ultra-deep networks. We've actually read this ResNet paper on this stream. You guys feel free to go back and dig up that stream, but right, it's this idea of having paths through the network that kind of skip, right? They call them skip connections, residual connections, but very powerful idea. Densely connected networks, DenseNet. Is this capsule networks? Yeah, capsule networks. I remember when people thought these were going to be very, very good. These came out of Hinton's lab, I'm pretty sure. And like he was promoting them for a while, but I think they just died off. Like nobody did anything. Because the problem is that there was a period of time where people were innovating in the architecture space, but the problem is that they weren't accounting for the fact that architectures and hardware have to fit, right? Like the architectures that work best on the hardware are the ones that are going to succeed, right? ConvNets, part of the reason they were so popular is because they actually work very well with GPUs, right? But capsule nets do not. Capsule nets are very clean, kind of from a hierarchy and theory perspective, but when you actually try to implement them in a GPU and try to get them to train fast, it just takes fucking forever, so no one used them. I think capsule nets are potentially obscure enough that maybe GPT-4 might not know. Let's see if it knows about it. Can you explain capsule networks for me? Actually, let's try something crazy here. In as if you were a pirate. Let's give it like a kind of a weird style transfer here and see if it actually does it. Let's see which ones have been nuked and which ones haven't. All right, this is gonna be great. Matey, let me tell ye about capsule networks, a fine piece of innovation in the land of artificial intelligence. You see, these capsule networks, or CapsNets for shorts, be a new breed of old neural networks designed to better understand the spatial relationships between objects in an image. Traditional CNNs be great for pattern recognition, but sometimes they struggle with maintaining the true spatial hierarchy and pose of the objects. Our swashbuckling scientist Geoffrey Hinton and his crew came up with CapsNets. CapsNets have a unique feature called capsules. Capsules are a small group of neurons that represent different properties of an object. And then the whole dynamic routing, which be like a trusty compass pointing into the right direct destination. That's kind of cool. Okay, so it understands that the way these capsule networks basically, the part that actually is not very good at being mapped onto a CPU or onto a GPU is this idea of dynamic routing, which basically means that the path that the kind of information flows through the capsule network changes, right? Because the layers at the bottom output, you could think of it like basically they're doing kind of similar to like a similarity search, where it's like depending on which things agree and which things don't agree, right? Like if those are pointing kind of in the same direction, then the information will get routed through them differently. So making the analogy of dynamic routing to a compass, that's definitely kind of impressive. All right, let's see if PDF-GPT has better or worse impersonation of pirate skills. Ahoy matey, let me tell ye about capsule networks. Look at this. This actually did the same exact. GPT, PDF, or ChatPDF and PDF-GPT, both of them have the same intro here. Ahoy matey, let me tell ye. Inspired by how our eyes work. Let's see if that phrase exists. Encoding primary modified convolution. The capsule contains the weighted sum, making it capable. So you see it lost the pirate. So it started off with the pirate, but then very quickly now this is just kind of like standard. Making it capable in traditional CNNs, a single cost function. This just reads like the paper. So we weren't able to basically override the formality of its output with the style request of pirates. You see, specific part. This also doesn't have the pirate theme to it, but here it is. It ends with the pirate. So it started with the pirate, and then it kind of just gives you kind of generic the actual kind of formal definition, and then it ends with the pirate. Versus PDF-GPT here, starts with the pirate, and then it just kind of goes on its normal rant, and then it loses track. It forgets that it's supposed to be talking like a pirate. So I don't think that necessarily, I mean, I don't know, draw the conclusion that you will out of this, but its ability to impersonate certain text styles, ChatPDF seems a little bit better than PDF-GPT, and both of them suck compared to GPT-4, right? GPT-4, it had like trusty compass. Like, it had the pirate theme was throughout the entire paragraph. All right, let's keep going here. Applications of CNNs. CNNs for solving the graph problem, image processing, and computer vision. Speech processing. CNN for medical imaging. Little activations functions here. You got a little sigmoid, you got the hyperbolic. Here's your little ReLU. See, part of the reason people use ReLUs is also because they're just simpler, like the equation is easier to calculate, right? It takes less computation to calculate this ReLU than it does to calculate something like a sigmoid or even like a GeLU. So that's part of it too, although I don't think that's realistically why people pick them now. They also pick them just because they work better. You got your leaky ReLU, so like you see how the ReLU here is flat, so anything in negative is going to return 0, but a leaky ReLU, if it's negative and it's really big negative, it's going to return a little bit of a negative, right? This x-axis here is the input, and then the y-axis here is the output. So if a neuron with a leaky ReLU activation receives a very large negative number, it's going to return a very small negative number. And you have this LU exponential linear union. It's basically just a little bit lower here. So here's a weird one. Parametric ReLU, PRLU. This is pretty obscure. I wonder if GPT-4 probably does not know about that. Who proposed the parametric ReLU, and when did they propose it? Oh shit. Did it get all these names right? Let's do Keiminger parametric ReLU. If it got all these names right, that's fucking insane. Oh, stop. Give me the paper. Keiminger Xiangyu Zhang, Xiaoqing Ren, and Jian Sun. Holy shit, dude. Like, GPT-4, it got all these name rights. Got this right, too. Like, GPT-4 is fucking strong. Delving into rectifiers, surpassing human-level performance on ImageNet classification. The paper was published in 2015. Damn. ReLU is a variation of the rectified linear unit, where the negative part of the function has a learnable parameter instead of being fixed at 0. So GPT-4, very, very good there. Very correct. Got all the names right. Got the date right. Very impressive. Let's see. PDF-GPT. The parametric ReLU was proposed by Keiminger et al. In 2015. Here you go. Proposed by Keiminger et al. In 2015. So this is one of those situations where PDF-GPT is GPT-4, right? So GPT-4 knows the rest of the people on this paper, right? But when you ask it this question, it's kind of like overriding whatever its answer would be normally with the answer in the paper, right? So even though it knows who the other people in the paper are, it gives you the Kaiminghe et al., which means just Kaiminghe and students, or whatever, because that's the way that it's said in this paper, right? So that tells you something about the PDF-GPT, where it has a very high strength on the paper, right? Which is kind of makes sense when we look at the pirate thing, where it doesn't really use the kind of raw power of GPT. It's almost more like a lookup. It's very good at just kind of like giving you exactly what's in the paper, and this is almost more like a search through the paper, right? And then ChatPDF, kind of a similar idea, right? Proposed by Kaiminghe in 2015. Proposed by Kaiminghe in 2015. So there you go. It's the same set of tokens, although at least here it kind of adds to that, right? It adds the sentence here as an improved version of the ReLU activation function. Versus here it says proposed by Kaiminghe in 2015, period, it is an improved version of the ReLU activation function. Right, and the way that this PDF says it, they start with that sentence, an efficient improved version of the ReLU activation function, and then they give you the date. So interesting how both of these GPTs here kind of had the same thing, where they give you the date and then they give you the sentence before the date, but in a slightly different format. Okay, we're moving. Optimization methods. So we got gradient SGD, which is kind of the most vanilla form of gradient descent that you can get. Add a grad, add a delta, RMS prop, and atom. There's a bunch more too. And here's another question we can ask. We can say, what are different optimization papers? Do you think it has read the whole paper? I don't know. It feels like it did it too fast. It feels like it very quickly found it. So I don't know if it's like reading it in the background, but it doesn't feel like it had enough time to like parse everything in this PDF and then start the chat. So there's probably some kind of like asynchronous stuff going on where like it initially just parses the first page and then it gives you the chat and then it keeps parsing in the background, but I'm not sure. Yeah, so I want to see here, I'm going to ask it what are different optimization methods for DL. And GPT-4 does not know this paper, so it's probably not going to give us this exact set of 5 here, right? It's probably not going to give us SGD, add a grad, add a delta, RMS, prop, and atom. It's probably going to give us actually a better answer, but if we put it into these here, the two ChatPDF and PDF-GPT, I bet you it's probably going to give us this exact set of 5 here. Yeah, so ChatPDF does deep stochastic gradient descent, SGD, add a grad, add a delta, RMS, prop, and atom, which is these exact 5 and in that exact order. PDF-GPT, oh, interesting. You see, this didn't give us that at all. So PDF-GPT here is just going on like kind of a weird generic rant here. Key difference, there are different optimization methods for DL. DL is employed where machine learning. Okay. The references it gives are page 3, 5, and then 29. And this one gives page 18. Okay, so this is kind of interesting. What this is telling me is that ChatPDF has a much more has a higher threshold for the similarity lookup, right? I don't know exactly how it's implemented, so I'm making a guess here. But at some point, it's measuring the similarity of your question to the text in the PDF, right? And obviously, different optimization methods for DL. This exact set of tokens is right here. Different optimization methods, right? So ChatPDF found the part in the text that has the highest kind of similarity, has that exact set of words, right? And it says page 18. But PDF-GPT, it gave us page 3 and page 5, which to me means that the lookup, the similarity threshold is like lower, right? It basically said, okay, as soon as I find something that's kind of similar to this, right, I'm just going to stop and then craft my answer based around that. So that's kind of my guess as to why PDF-GPT gave us a summary of something based on page 3 versus ChatPDF gave us the one sentence answer that we were looking for specifically from page 18, right? So there's maybe something there with where do you start the search, from the top of the PDF or the bottom of the PDF? Do you search the entire PDF and then find the thing that matches the most, or do you start searching and then stop as soon as you find something that's within a certain type of similarity of what you actually want? And let's see what GPT-4 gives us. So GPT-4 gives us gradient descent, SGD, mini batch gradient descent, momentum, Nesterov, accelerated gradient, AdaGrad, RMS prop, AdamAx, and Adam AMS grad. So this is actually the best answer, right? So GPT-4 not only gives us every single one of these, but it also gives us more of them, right? So I don't know, kind of what I'm learning here is that if you want to learn things, GPT-4 is better than these PDF specific ones, right? Here you have gated recurrent units and LSTMs. These used to be very popular for sequence tasks, specifically in the natural language processing, but they've kind of been thrown away now for transformers. Transformers are just better. I think they still use them in certain situations. I think like some robotics use cases still have recurrent neural networks, and like sometimes you'll see video models that have like the ideas of recurrent neural networks in them, but I would say largely LSTMs and GRUs or GRUs or whatever you want to call them are dead. Variational auto encoders. Where are we at? What's going on here? Okay. KL divergence of latent, which determines how closely the latent variable is in match with a unit Gaussian distribution. You want the latent distribution to match a different type of distribution, and if you want two distributions to be the same, you use the KL divergence as the loss, or at least as a component in the loss. This is what some of the first GANs look like. Right, like you think about Midjourney and then realize that this is where it started. This is what it used to look like. Just look how bad this looks. GAN for medical imaging, deep reinforcement learning. So deep reinforcement learning is reinforcement learning, but where the value function and the policy are approximated with deep neural networks, which are basically universal function approximators. So, because reinforcement learning, believe it or not, actually has a very long history, and there was people that were doing reinforcement learning before you had deep neural networks as function approximators, and they literally had like tables, right? They would have a table where every single state that the system has run into is evaluated, and the value function is literally a table, which is weird to think about. I think that's how they solved backgammon, which is kind of like a weird form of chess. Partially observable Markov decision problems, POM-DP. Fuzzy RL, what the fuck is that? Myths about deep learning. So it's just kind of explaining how to do transfer learning, right? So you take a large network that's been trained on ImageNet, and then you just fine tune it on your specific problem. Hardware for deep learning. The tensor processing unit. I think the TPU v4 came out recently, right? Optically reconfigurable supercomputer. Here's a bunch of what if we ask it something very let's ask it something like extremely niche here. What is a link to the Can you provide a link to the Stanford question answering dataset? SQUAD. All right. So, I mean, there's no way GPT-4 is going to know that, right? That's like extremely obscure, and it's like specifically this. I'm looking for the Raj Prakar GitHub.io. So I'm going to put that in there, and I'm going to ask all of these. Let's see what they say. Okay, so PDF-GPT gets it pretty much spot on. Here you go. Can be accessed through the following link. Raj Prakar GitHub.io, Raj Prakar GitHub.io. So I got the link right. ChatPDF also got the link right. Found it instantly here. Raj Prakar GitHub.io. So that's good. Now let's good old GPT-4. Holy shit, dude. What the fuck? How does it know that? That is insane. Damn. Okay. So, I mean, obviously, when I saw these two PDF little bots get it, I'm like, of course it is. It's like just one of these random links down here. It like finds the similarity. This is kind of a unique set of tokens here, and it gets it. But the fact that GPT-4 knows it, that's insane. All right, so maybe the title of this video should be like, don't ever bother using this, the PDF readers, just literally ask GPT-4 and GPT-4 is gonna know, and you don't need to do that. Which maybe is a commentary on kind of this idea of task-specific intelligence, right? I feel like for the past 50 years, right, task-specific intelligence has always beat general intelligence, right? Like if you had a machine learning model that was trained on a variety of different tasks, it would always be beat by machine learning models trained on each of those tasks specifically, right? But that's no longer the case, and more you're seeing that the general AIs are better than the task-specific AIs, right? And that has huge repercussions for kind of the world and the market, right? Like, what's the point of creating a PDF-specific AI tool where you can give it a PDF and it allows you to answer questions on it if GPT-4 itself can just answer those questions for you without ever having to read this PDF, right? Like, what's the point of PDF-GPT.io and this like product that's based around a specific PDF if GPT-4 just answers these questions for you perfectly? That's fucking crazy. Okay, so we're gonna do, so right now we've been kind of exploring deep learning. I'm going to try something new here. I'm going to do a new chat, and I have a second paper here that I picked, and this is a paper on history, like kind of like this weird computational archaeology paper that actually comes from the Discord for the Scroll Prize, believe it or not. Somebody recommended it there, which is pretty cool, but this stuff is obscure, right? Like, this is like some next level obscure stuff. So I'm curious to see what happens. New PDF and new chat. We're going to upload this one because this one is extremely obscure, and we're going to see if GPT can get this obscure one. Okay. Okay. Reconstructing ancient architecture, blah, blah, blah. Okay. So let's scroll here and let's ask it something like fucking crazy obscure here. Figure 9 is an example of photogrammetry test case in near identical circumstances. See, let's find something weird here. Here we go. All right, here's something fucking obscure. The majority of the ashlars were modeled from field notes of J.P. Protson, who conducted his fieldwork over a number of visits in the mid-1990s. The field notes from Léonce Engrand and Max Uhle in 1893. Okay. Who and when were the original field notes for Tiwanaku in Bolivia? Who and when recorded the original field notes for, what do they call them, blocks? Ashlars in Tiwanaku in Bolivia. Okay, if ChatGPT gets this, I don't know what I'm gonna do. I'm gonna have to leave this house. Okay, so let's put it in there. Okay, so ChatPDF, according to page 9, the original field notes were recorded by J.P. Protson in the mid-1990s. Okay, so it's finding it. This is page 8 or whatever. Léonce Engrand in 1848. That's also correct. And then Max Uhle, 1893. Okay. Boom. ChatPDF got it pretty good. Let's see PDF-GPT. It died? The fuck is this? Go. Search for me. What? New PDF. Did it just die? Okay, so it looks like this thing just died, which is no good because it had a very good little UI. So, I mean, I liked the UI for this one, but the fact that we just caused it to error out is no good. So far, ChatPDF kind of giving us the right thing. So here, moment of truth, guys. Let's see if ChatGPT got it. Oh, shit. Bolivian German archaeologist Max Ulla in 1895. Max Ulla, 1893. Very, very close. Like, disgustingly close. 1960s and 70s, further investigated by Arthur Pronounsky and Carls Ponce Sanguines. Okay, so it didn't get Léonce Engrand, didn't get JP Protzen, but it did get Max Ulla, and it did get the date, which is pretty impressive, right? Because realize that GPT-4 does not have this PDF. It is just knowing this from memory. Let's give PDF-GPT one more try here. Let's upload the file. Again, hard refresh. Let it output its little thing. Still no good. All right. We might have killed PDF-GPT. It might be dead. Let's try to find one more kind of obscure thing here. We use two basic forms of printing, filament or polymer. Part is printed layer by layer. So how about this? A Z Corp Z310 rapid prototyping printer. Let's see. What is a Z Corp Z310? And then let's come here. What is a Z Corp Z310? And then what is a Z Corp Z310? According to page 12, Z Corp Z310 is a rapid prototyping printer that uses powder-based printing technology, powder-based printing. Okay, that's correct. Similar to an inkjet, but instead of ink, it lays down layers. In the same way as an inkjet printer. Powder material also acts as the support structure. Since powder print is in a matrix, the powder acts as the support structure. Okay, so ChatPDF basically gave us this paragraph here, and then it kind of selected a couple different parts of it. See PDF-GPT. The Z Corp Z310 is a type of powder-based 3D printer that was used in the process of creating 3D models of the andesite building. Laying down a layer of plastic powder into a print bed and then depositing a printing agent. Laid down into the print bed, there you go. You're finding these like same little sequences, right? Depositing a binding agent. I bet you that's probably somewhere over here. Deposits the binding agent. There you go. I like the succinctness of ChatPDF. Like, usually if I'm asking questions about a PDF, I want it to just kind of answer. of course, guys. GPT-4, it knows. It doesn't need your PDF. It doesn't need knowledge. It already knows everything. Look at this. The Z Corp C310, also known as the Z Printer 310, is a 3D printer manufactured by Z Corp, a company that was acquired by 3D Systems in 2012. Let's just double check that. Z Corp, not Z Crop, Z Corp. Acquired by 3D Systems on 2012. Printer works by spreading a layer of powder material onto the build platform. Print full color. God damn. Dude, like GPT-4 knows about printers from like the 80s. Shit. Maybe it's not the 80s. This is like a 2000, sorry. On what data is GPT-4 actually trained? Well, we don't know. OpenAI won't tell us, but we do know we can make some educated guesses. I think it's probably trained on Wikipedia. It's probably trained on Creative Commons license or something like that. Creative Commons. It's probably trained on every single like book that is old enough to where nobody can sue you. But at some point, there's going to kind of be not enough training data, right? And right now, you're seeing all these companies kind of competing to get the training data. And even some things, like, for example, Quora, I think is Quora, Reddit, Twitter, Facebook, Google. Like, those are all companies that have big data sets that OpenAI can't train on, right? OpenAI can't train on every single picture in Facebook, every single piece of text, and every single piece of information that someone put on Facebook. But Facebook can, right? OpenAI can't train on every single tweet ever written, but Twitter can, right? So I think you're going to see different GPTs, or basically LLMs, trained on different types of proprietary data. But kind of what we're learning here is that the GPT that's trained on as the most data actually performs the best. And like these kind of ones that are specific to this PDF and filter things in the PDF, not as good as just the vanilla GPT-4. Effort to advance virtual reconstruction of the building. What is andesite, by the way? Like, what the fuck is that? Andesite? Is that some kind of stone? A type of volcanic rock of intermediate composition. Silica-poor basalt and silica-rich rhyolite. Okay, here I got one that's potentially not going to be get by ChatGPT. We're going to say, what university houses the School of Art and Architecture, as well as the Young Research Library? American companies don't have data privacy rules either. Like, that's you know, I think Chinese companies have the advantage because WeChat, for example, has both financial data and text data. So like WeChat is a weird combination of like multiple apps, right? Like it's kind of like the Facebook and the finance at the same time. So that particular combination makes it kind of unique and powerful. And then they also just have, China just has more people, so they have more data. But I've also heard stories that apparently the data in China is not as clean or something like that. Like someone was trying to tell me that it's like more consistent, so it's actually difficult to, you don't get the variety that you get in kind of the English in English internet. But I don't know. I suspect that the Chinese LLMs will be very strong as well. Okay, so ChatPDF. PDF does not contain information about which university. However, a quick internet search reveals that these facilities... What? Does this have toolformer capabilities? There's no fucking way. Can you search the internet? Are you a toolformer? Damn, I did not know that. ChatPDF, kind of impressive if you can search the internet. Ooh, look at that, nice. Page 2 of 20 and then page 19. Okay, so kind of interesting there. ChatPDF did not find this information, but PDF-GPT did find this information. I think part of it is because the way that I wrote this question was a little bit unusual, right? School of Art and Architecture and then Young Research Library. These two are perfect kind of token sequences that you could search with similarity, but they're interrupted by this stuff here. So maybe the way that ChatPDF kind of creates tokens for this, or creates some kind of vector that it then uses to do similarity searching, it's like doing it for entire paragraphs or something like that. But let's ask it the question here. Let's see what it has to say about that. No, I cannot search the internet. Finally, let's ask her good old GPT-4. GPT-4, of course, knows. See, to me, this is just interesting. Like, GPT-4 just knows everything. You know, I've kind of like reevaluated, I've like been thinking deeply about what it even means to read papers anymore, right? Think about it. We just fed it like 2 different papers here, like deep learning, this weird archaeology paper, and it knows all these questions. And it's starting to get to the point where if this is GPT-4, right, and you have GPT-5 and then 6 and then 7 and then 8, what's the point of reading papers, right? Like, is it going to be actually stupid to read papers? And if you want to learn about something, you just ask GPT-4 or GPT-5 or GPT-6? I feel like we're starting to get to that point right? Where it's like reading books will be replaced by just asking GPT about these books. Reading papers will be replaced by just asking GPT about these papers, right? And then what happens to papers when they're no longer being read by humans, right? Like what happens to deep learning and the machine learning's community kind of like paper format and like these type of papers where you have abstracts and then you have things like that. Like, does the format change when nobody actually reads these papers, like actually reads them, and everybody's just reading them with GPT-4, right? Do you change your paper format such that it's more consumable by GPTs and LLMs, right? A similar kind of thing is happening in software where people are starting to ask themselves the questions. Yeah, but like, for example, in software world, people are starting to ask themselves the question, should we design our API such that it's easy for a human to use or easy for an LLM to use? Right? And that's not a stupid question. That's a real question. It's like, hey, how can we design the names of the functions, the name of the keyword arguments, the names of kind of the responses for our API such that it's easy for an LLM to understand and it doesn't get confused and doesn't use a ton of tokens and so on, right? Versus how do you design an API for humans? Human readability is a big part of it, right? So I don't know. I feel like we're on that curve, guys. We're like literally the exponential curve of the singularity, and we're on it. And I don't know, just crazy time. So maybe I'll end it here, a little bit over an hour, but the TLDR that I have for you guys is that neither of these PDF tools are better than GPT-4. GPT-4 seems to be the king. Both of these tools, kind of similar. ChatPDF didn't error out. It provides a little bit more succinct. It didn't error out. It provides a little bit more succinct answers, and sometimes it doesn't get the right answer. PDF-GPT, I think, has a better UI because you can see the PDF at the same size. It also has these references where you can click and it'll take you to that page. So a slightly better UI. It's a little bit wordy sometimes. So like sometimes it gives you a little bit too much information versus like ChatPDF kind of makes sure to summarize it very clean. And sometimes it just straight up errors out. So like right here, we were trying to ask it a question, it just kept erroring out. So that's the review, guys. Don't use ChatPDF, don't use PDF-GPT, just use GPT-4. Hope you guys have a good weekend. Hope that was interesting and or useful. And feel free to drop on the Discord to recommend more content and what you guys want to see. Like and subscribe, and see you guys later.